Welcome back, you guys. This is day 6 of our Learn to Do Web Development with ChatGPT. And yeah, we took a little bit of a break. I've been trying to set up YouTube Live. I think we have more of an audience on YouTube instead of Twitch, so we're going to try to move things over. I requested the account today to go to YouTube Live, and it takes around 24 hours for YouTube to honor the request and set everything up, get your channel ready. So I'm going to still stream on Twitch today, and we're gonna see just this thing, and we're gonna try to finish up the React tutorial. So we're getting close, right? Just a reminder what we did last time. Last time we were working on the tic-tac-toe tutorial. Let's switch to our desktop view. So we're doing our tic-tac-toe tutorial. As you guys recall, we were able to get some CSS going to create this square box, or this checker box, for our tic-tac-toe game. And we were able to get each component to register a click and fill a square with our click, like so. And then we were able to, we basically made a component that had a state machine inside of it, using the React props, or using the React use state, what is it called? The React use state method. And after we were able to do that, we noticed that we couldn't control each of the blocks as a unit. Each of the blocks had its own state, and we needed to be able to control the state together and coordinate the squares. So in the last tutorial, we lifted the state to the next level, to the board level, and the board was able to control each of the squares and tell the squares to fill itself in. So let's try to continue the tutorial and finish this thing up. So I think last time we were at this spot. Okay, yes, that's right. So we used the React developer tools. We're at this spot. So let's take a look at our application. So what we have here is, let's restart this browser. We have 9 squares. Each of the squares is represented with an array, and each array is filled up with nothing right now. The state, the React use state, which is the React hook, is inside the main board, and we filled up the array. We filled up the initial condition with 9 squares, an array of 9 squares, and then we went ahead and lifted the state, which means that we took the use state from our square function and we lifted it to the board function, and then we passed on a function. Oh, that's right. We also learned about arrow functions. So we were able to pass on the arrow function. This is the arrow function. We passed on the arrow function from the main board to our square, and the square is able to take a parameter. So handle click 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, so continuing on to the tutorial. Let's see what it has to say. Completing the game. By this point, you have all the basic building blocks for your tic-tac-toe game. To have a complete game, you now need to alternate placing X's and O's on the board, and you need a way to determine the winner. All right, so it seems like we have to lift the state up once again. So currently, each square component maintains a part of the game state. Oh, okay, I'm sorry. We already did so. Okay, so this is what it's telling us to do. It moved. Okay, so we moved this to the board component. Oh, I see. Let's take a look. Oh, that's right. Okay, so we did this ourselves. Apologies, it's been a few days since I've looked at this. I was busy moving our stuff to YouTube. We are at this point. Okay, so we basically move our hook, our set state hook, to the board, which is what we did. Now we can replace this array with a series of squares. So let's copy this thing, right? Let's copy this and use that as our initialization. So that's pretty cool, right? So now we're saying that, hey, look, array index number 0 is going to be filled with 0. Array number 1 is null, x, x, o, o, and null, null. These are the initial conditions, so whether or not you clicked it, it's going to have those values, right? And as you can see, if you click on it, it's still gonna go back to x because we're calling handle click inside the on square click method, which fills in that array with an x, that array index with an x. Okay, so now we pass down the values to each prop, great. And then we'll edit to square to display it, great. And our code looks like this. Okay, so that's essentially what our code looks like. Now, each square will now receive a value prop that will be either x, o, or null for empty squares. Next, you will need to change what happens when the square is clicked. The board component now maintains which squares are filled. You'll need to create a way for the square to update the board state. Since state is private to a component that defines it, you cannot update the board state directly from square. Instead, you'll pass down a function from the board component to the square component, and you'll have square call that function when it is clicked. You'll start with, okay, we went through this. So we learned about arrow functions. Okay, that's right. See, this is why we should stay consistent with streaming, because if you forget to stream or you're busy with streaming for a few days, you forget your progress. Immutability. All right, we did this already. Okay, cool. Okay, so we're on taking turns. Cool. So we discussed immutability last time. So we even looked up with ChatGPT. Immutability is important because React hooks, the useState hook, manages the state based off of the existing state of the system. So if you have objects that change, then it's very hard for React to tell what happened to that object. In order for React to know more easily how to handle an object, if you make it immutable and you replace the whole object, then React easily knows that you've changed the reference and it'll re-render the screen. If you don't do so, React needs to do a lot of work to figure out what's happening, and it's not good for performance. And that's why we were calling the slice function last time. All right, so now we're gonna fix a major defect. The O's cannot be marked on the board. We're gonna set the first move to be X by default, and then we'll keep track of this by adding another piece of state to the board component. Okay. X is next. Set X is next. Okay. Each time a player moves, X is next will be flipped to determine which player goes next, and the game state will be saved. You'll update the board's handle click function to flip the value of X is next. All right, so what are we doing? We're gonna add one more state to our board. The state, make sure the state keeps track of who is next, in whose turn is next. And then we're gonna do some logic over here. When you click it, it's gonna flip who is next. And then we're just going to, if X is next, we're gonna flip it. Oh, I see. Okay, so this is saying if the X's next state is true, then we're gonna display an X. If it's false, we're gonna display a 0, and then we'll flip the bit every single time, right? The not, this is the not operator. It basically inverts the bit. All right, so let's do that ourselves. How are we gonna do that? So we're on the board component. We're gonna introduce a new state. So to do that, we make a constant list, and the list has two elements. The first element is the state that we want. So is X, or X is next. Okay, so is X next? And then we need a way to set X is next. And let's see how they capitalized it. Okay. So they use camel. So I guess camel case is the convention. Okay, so now we have an array. We need to define the array. So we're gonna use we're gonna use the hook use state, and then we're gonna give an initial condition. So who goes first? Let's say X goes first, right? If X goes first, then we're just gonna do true. So X will be next on initial boot up, and that's what they did too. Now we gotta do some logic to display X is next, right? So inside handle click, let's see, right here we're saying the next square is gonna be X, but that's not what we want, right? We want next square to be X only if X is next. Okay, and then if X is not next, we're gonna say next squares is going to be an O. Great. All right, so let's see. What do you guys expect this to happen? Or what do you guys expect to happen, right? Right now, at this point, X is next is never updated, which means that it's always gonna go to this, branch, because X is next is never changed from true. And if it's true, it's gonna do X. So if we refresh this page and we try to click, you see it's all X's. All right. So how do we flip it to O's? Well, if you don't want it to automatically switch every time, you just set the initial condition to false, and let's see what happens. Now we set everything to O's, right? Okay, so let's keep X as the first player. Now, the most important step is over here, right? At the end of our function, we need to be able to flip the bit. So we're gonna say set X is next. This function will set the parameter, and then we're gonna say not the current X is next. Okay, so what is this logic saying? At the end, we're gonna set the old X is next to not X is next, so flip it. Okay, let's see if it works. X, O, X, O. Okay, so you see, it basically switches every time you click it. That's awesome. That's pretty fun, actually. So let's set this as an array. Now let's practice our syntax. How do we make an array? If I recall, we can do array.fill 9. I think this makes an array of 9, but I may be wrong because I'm not very good at JavaScript, which is why we're doing this in the first place. Okay, it's not happy. What did we do? Oh, array of 9, and then we fill it with null. I see, so that's the syntax. All right, so we want an array of 9, and then we want to fill them with nulls. Not the string null, but with actual nulls. All right, let's see. Bam, 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 bam. Okay, have you guys ever played tic-tac-toe with yourselves? Excuse me. Excuse me. Oh, excuse me for that. I have definitely never played myself in tic-tac-toe, and it seems like it's harder than it is. Okay, so that's our goal. Let's continue on. So we're able to do that. Now, when we click on each square, it's gonna flip. Great. The X was overwritten by a 0. Oh, I see. So, okay, so now it's saying that, hey, when we click one of the existing squares, it's replacing that square with a value, and that's not what we want, because you don't want to overwrite your enemy's moves, right? That doesn't make for good tic-tac-toe. So what do we have to do? Okay, so we can fix this by, so when you mark the square, you aren't first checking to see if it's already there. You can fix this by returning early. You'll check to see if the square has an X or a 0. If the square is already filled, you will return handle click before it tries to update. Okay, All right, that's a easy and quick way to do it. So they're saying that first we're gonna if next square slice squares. Okay, so let's take a look. Squares. Okay, so we don't even need to use a slice. Yeah, we don't need to use next squares. We can just use the regular squares because we're not modifying, we're just reading. And then we're gonna return. Great. Now, is it happy? Seems like it's happy. Okay, let's repeat this. So, great. I'm clicking on these guys and nothing is changing, right? Cool. That's pretty cool. So we're getting very close to real tic-tac-toe. All we need to do is the score counter now, I guess. So now we can only add it to empty squares, and this is what our code looks like. I think it's very similar. Okay, so declaring a winner. I'm pretty excited, guys. We're almost done. So we're almost at the last section. Declaring a winner. Now the player can take turns. You'll want to show when the game is won, and there are no more turns to make. To do this, you'll add a helper function called calculate winner that takes an array of 9 squares, checks for a winner, and returns X, O, or null as appropriate. Don't worry too much about calculate winner function. It's not specific to React. All right, so this is some game logic that they've written for us. I guess the point of the tutorial is to learn React and not how to figure out how to win a game, like how to keep track of winners in the game. But let's take a look at this code anyway. All right, so what is this saying? To calculate winners, we have these lines. What are these lines? I'm assuming these lines are arrays where someone is a winner. So let's take a look at this. I'm gonna split the windows in two. Go back to these. All right, so what does 0, 1, 2 represent, right? Let's take a look. All right, so 0, 1, 2, that's one line. 3, 4, 5, that's the second line. 4, 6, 7, 8. 6, 7, 8, that's another line. Okay, so that considers blah, blah, and blah. So first row, second row, and third row. That's the first 3 lines. Next one is 0, 3, 6, 0, 3, and 6. 1, 4, 7, 1, 4, 7, and 2, 5, 8. Okay, so it looks like the first 2. Oh, so these are all the winning combinations, right? They're basically, you can only win 1, 2, 3, 4, 5, 6, 7, 8. There are only 8 ways to win in tic-tac-toe, right? You have the only way to make a row of 3 is all the rows, all the columns, and the 2 horizontals, or the 2 diagonals. So these are all the winning combinations. And then what's it gonna do? It's gonna go through every line. Okay, so it's gonna go through every winning combination. It's gonna look, okay, that's not too bad, right? This one splits the line into 3. Okay, so okay, that makes sense. So this is the I forget the name of it, but it basically list comprehension in Python. I don't know in JavaScript what you call it, but deconstruction. It's like array deconstruction. So it deconstructs this array to the first element, second, and third, and we're gonna say if A and okay. So basically, this logic is saying, hey, the squares for A, is that the same? So return true for if A, so A is the first line, if that's the same as the next one, and that's the same as the third one, right? So if this and that, then return squares A. Okay, squares A. So what is squares A? Squares A is the value. So how do we logical AND values? Oh, squares A's is a Boolean. Did we keep track of squares as a Boolean? Let's take a look at the code. All right, so my question is, how can it just say that, how do I unzoom? My question is, how can it just assume that, like, what is if squares A, right? Like, is this true or false? So if squares A, so squares is defined as an array with a fill of not, so it's an array, and what are we filling it with? X's or O's? Okay. So this is where ChatGPT comes in. Let's try to use ChatGPT. Let me first log in. Okay, great. And then let's go back to our old chat. Hi. Good afternoon. We are almost done with the React tutorial. It's quite exciting. We want to understand the example in the tic-tac-toe game, and this is the code in question. In the tutorial, squares is defined as a list of strings such as X or O or null. How does this check for equivalence for all the squares? Okay, so as I'm typing this, I think I answered my own question. This method is not meant to check if all of the squares are the same. It's just checking which square. Let me take a look again. Where is it? Okay, right here. It's checking squares A is one of the spots. If squares A, oh, 0. So 0, 1. So this is saying if something is in those lines, then we return that something. Let's read down. You will call calculate winner to check if a player has won. You can perform this check at the same time you check if the user. Okay, let's give it this whole thing. All right, let's see. For all the squares being the same string. Okay, let's see if it understands what we're trying to say. Okay, so squares array is used to represent the state of a tic-tac-toe game. The elements are either X, O, or null. The condition has 3 rules to be true. Squares A, this checks if the value is truthy, not null, blah, blah, blah. This ensures there is no non-value. Okay, that's right. This checks. Oh, I see it. Okay, right, no, this is fine. If it's equal to the value at here. Oh, I see. Okay, so it's saying that using triple equals, it not only checks if it's equal, as in if it's like, if it has something, but it also checks if it actually equals the same value, right? That makes sense. together, blah blah. Means that there's a winning. Together, these conditions check if A, B, and C in the squares are the same and not null. If all three conditions are true, it means that there is a winning combination. The code inside the if statement then executes the logic for handling winning. Okay, let's take a look at this one more time. Okay, so this is saying if the first square has something and the first square is the same as the second square and the first square is the same as the third square, then it's a winner. Okay, that makes sense now. Okay, I don't know why I got tripped up on this. I think that, I'm not sure. But okay, so we understand it now. It's basically saying for square A is the same. So if square A exists, if square B is the same as square A, and if square C is the same as square A, then we have a winner. All right, so this makes sense. Let's try to write this ourselves real quick. So where are we? Okay, we should define the function up here. Okay, so we'll define check winner and then we take in squares. Okay, so what do? We're gonna define the table of winners. So winning combo is going to be a set of, it's going to be a list of winning combos. And we said that there's going to be 8 winning combos. This is the first 3 rows, first 3 columns, and then 2 more for the diagonals. Okay, in the first row, it's 0, 1, 2. This is 3, 4, 5, 6, 7, 8. The next one is just 0, 3, 6, right? The numbers are here. So another winning combo, 0, 3, 6, right? Straight down. The next one is 1, 4, 7, straight down. The last column is 2, 5, 8, which is straight down here. And the diagonal is 0, 4, 8. And the other diagonal is 2, 4, 6. Right, so you can see the diagonal is 0, 4, 8 and 2, 4, 6. All right, so with the winning combo, okay, so we need to let, or this will be a constraint. And then how are we going to check for a winner? So we're going to loop through for each line in winning combo. And apologize, I come from the Python world, so my JavaScript may be terrible, but I think that's how you do a if statement. So for let line in, does that work? Okay. Then we're gonna go line by line. If, okay, so we need to do a list comprehension. So line, so A, B, C is going to be line. Okay, so we're gonna do a list comprehension on the line, and then we're gonna do an if statement. If each line, if, okay, so if squares in the first, if there is something in the first one, and if the first one, the first list element or the first block is the same as the second one in the list, and if the first list element is the same as the last list element in the winning combo list, then we're gonna declare a winner by returning the first element, which is X or O, else we're just gonna return nothing. Okay, so how did we do? Let's see. Okay, so first thing is we're missing a semicolon. I don't think you need it, but it's nice to have. And let's look at the logic. So they're calling it calculate winner. Let's just call it calculate winner. Calculate winner. Okay, so they call this lines, we'll call it winning combos. I think winning combos is a better description. I think that JavaScript probably uses camel case. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 3, 6, 1, 4, 7, 2, 5, 8, 0, 4, 8, 2, 4, 6. That's correct, right? So our logic is correct. And then it's gonna do a for loop. So I don't know if JavaScript, let's see if our JavaScript works. Let's look it up. Let's ask ChatGPT. Can you write a for loop in JavaScript with a for each? Let's see. Okay, so there's a for each. Let's ask if this is valid JavaScript. Is this valid JavaScript? Oh, so it's not recommended. Why? The for in is used to iterate over properties of an object, not elements in an array. When used with an array, it'll iterate over the indices of the array rather than the actual elements. Oh, interesting. For iterating over arrays, it's better to use the traditional for loop or a for each, as I showed in the previous example. Okay, very sassy. Just kidding. However, the recommended approach for iterating over arrays is using for each or traditional for loop. Okay. Okay, so we learned something new. In JavaScript, it's not like Python. I come from the Python world. You can't just do, well, you can, but I'm sure it's gonna give us some weird result. So let's not do that. I mean, I'm not, like, this will give us the index. Basically, line will be 0, 1, 2, 3 until 8, or like 7. So let's change it to the way that we like. I kind of like the for each, but I also think a regular for loop is fine. All right, let's try the for each. So winning combos dot for each. And then we need an arrow function for each. Yeah, I see. Oh, I see. Okay, so, all right, guys, here's the thing. Can we use that for each method in this case? I think the answer is sort of. All right, so how does this work? In order to use this for each function, we need to replace this with an arrow function, all right? And the arrow function will do something, right? So if we did this, and then we pasted this in, what do you think will happen, right? It's gonna go through each line. It's gonna go through each line, and then it's gonna do this function. And it's gonna return null the first time it sees like a non-match. When that happens, I think it's just gonna exit this function, right? Which is not what we wanna do because it will give us a false answer. So this actually probably is not correct. Let's see, the way they did it was, right, you return null at the end. So, oh, actually, I wrote I wrote our script wrong. This else should never have been inside the for loop anyway. Okay, so the way we did it, the way I did it was wrong. So we can use for each. Let's fix it. Okay, so this else definitely should not have been there. This should have been outside here. So this is saying if it never found it at the end, let's exit. And then we can replace this with a for. Okay, so this we can do for each. So we do winning combos, winning combo for each, and then we'll make an arrow function. Arrow function takes the line as the argument, and then we'll finish this off. Okay, I'm the worst with finishing braces. Great. I think this is better. Indent this properly. Okay, so I think this should work. The saying, so for every line in winning combos, we're gonna check if the squares line up, the square of that element lines up. Okay, so the next part is we're gonna check to see if for every time you click, is there a winner, right? So let's calculate winner. So if every time we click, when we're done, okay, so when we're done, we're gonna calculate winner, and we're gonna give it squares. Actually, we're gonna give it next squares, because that's the next move. And then if calculate winner, then we're gonna console.log the result. Okay, so let's save this to a variable. So const, let's see, let, we could do const, I guess. Const one did win. Okay, great. So we save the result of calculate winner, and then we're gonna log did win if there is a winner. Let's see, does this work? The good part is there's no crash. Oh, this is not defined. Okay, so clearly I did not type in squares properly. Squares, squares, and squares. Okay, let's try again. Boop, 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 boop. And nothing popped up, even though we have 3 winning combos. All right, so clearly we did something wrong. What did we do wrong? Did we even get in here? Let's see. Let's see if we even go into this for loop. So we're gonna console.log over here, in loop. Okay, so this is how you debug, right? You just place a breakpoint. Great, so we are in the loop. It performed the loop 8 times, as you can see over here. That's great. Let's see if it is able to return a good result. So this is 1. So boop, 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 boop. Oh. Okay, so nothing. So basically, we returned before we could print. So let's do it one more time. Okay, so our logic is correct. We detected the winner, right? We won. So what's the problem here? The problem is here, did win. Can I do let here? Is it because I defined it as a constant? So we're gonna calculate winner. If did win, log did win. All right. Try one more time. X, oops, blocked myself. 1! But that was from here. We didn't print out did win. Y. So we do calculate. So what is did win? Let's just print out did win every time. So what is did win? Okay, x. So did win is null. Still null. Okay, so calculate winner is not returning something. Ah! Okay, I don't know. Do we need to define a return type? I don't think so. What is the problem here? So when we return squares A, what is squares A? Let's check out what squares A is. Okay, so we know x is the winner, so it does return the right value. Interesting. Oh, maybe this return returns to, I see. So I'm guessing this return doesn't return outside the loop, it returns here. So let's see, got here. So we should not see got here when, okay, so we see got here because it didn't return, right? We haven't returned yet, but we shouldn't see it when we're winning. And it seems like it still goes out here. So this return actually just returns out of, okay, that makes sense. This return just returns out of here. So to get this for loop to work, we need to return one more time. So we actually need to return squares A. The only problem is if squares A is null, then, okay, so there's a slight problem over here. You got to keep track of this when you return. This is kind of a pain. I think a regular for loop is a little bit better, so we don't need this extra arrow function. Let's just use a regular for loop, or else it's unnecessarily writing unnecessary code. So let I is equal to 0. I is smaller than the length of winning combos. The length of winning combos. And then I plus plus. So this is 0 to whatever the length is, minus 1. Or not minus 1, but less than that. So if the length is, so if the length is 9, we have 0 to 8. So this is 0 to 8. Great. And then we're gonna go here to grab our content. Which is this over here. We're gonna stick that into here. And what is this complaining about? I has already been declared. Has it? Where? Okay. We'll figure that out in a second. Let's fix this stuff first. Okay, so we're gonna remove all this, and we're gonna return null here. And then we're saying a for loop is not written correctly. So how do you write a for loop? Let I is equal to 0, I is smaller than blah, right? That's normal. So why is it telling me, I see. It's not a comma. Or it is a comma. No, semicolon, all right? Oh, I see. Oh, there you go. Okay, so the compiler didn't like that it's missing an I. It's like, what do I plus plus? Okay, and then this one is winning combos and the index, right? Because we want each line in winning combos. Now let's try this again. So, x, x, x. Bam! 1 and return X. Okay, so this is cool. So you see we don't have that problem because now the scope is the for loop, and this for loop doesn't have its own arrow function, which means that we're escaping the main function instead of escaping our arrow function. Let's get rid of all of this logging, debugging messages. And that's how you guys debug. You need to be able to put breakpoints where you want, and then take a look at the state of the system where the state of the system is. Okay, let's try that. X, 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 bam, that's the winner. And then now I think there's gonna be a bug because, or it's not a bug, but basically if there's 2 winners, okay, I can't even win if I'm trying to. Okay, there we go. So this printed X twice because, why did it print X twice? Because it already checked. Okay, so basically it checked in order, and the first order it found was 0, 1, 2. And then it found 3, 4, 5. If we flipped it and did X's on the bottom, all right, then it's still gonna be 2 X's, but if we flip it one more time, put X's on there, it's gonna be O's, right? So O is the winner now. Okay, anyway, back to the tutorial. We're almost there, so close. Now, we're gonna do handle click if squares. So we'll call calculate winner to check if the player has won. We can perform this check at the same time you check if a user has clicked a square that already has an X or an O. We like to return early in both cases, right? So if you click on the square that already has an X or an O, oh, I see. So if you do that though, but when you do that though, that means that the user needs to click once more to register the win, right? Okay, so let's try it out. X O X O X. How did it know that it won if you calculate it up here? Oh, I see. So they do it one more. They call calculate winner one more time at the end. Why do they do it twice? You calculate winner. So if there's a winner, return. Oh, I see. If there's a winner, return. Oh, so you don't want invisible. I see. So right here, you don't want invisible winners. I see. So basically when you click, it may still update the board content even though you have a winner. So you don't want something to happen, right? I see. So we'll call calculate winner to check if the player has won. If it's won, then we want to return early. So this is not to check for winners. This is literally so that a user can't continue updating the game after somebody has won, which is a good thing to do. Let's do that ourselves. So in our board component, we want to check. So is calculate winner square or. Okay, so this one ensures nobody can do anything if there's already a winner. You cannot modify the game. The next part is, how long have we been streaming for? Almost an hour. The next part is displaying if there is a winner. So it's gonna do it's gonna grab who the winner is, and then we're gonna show the status of the winner. So to let players know if the game is over, you can display text as winner X or winner O. To do that, add a status section to the board component. I see. The status will display the winner if the game is over, and if the game is still ongoing, you'll display which player's turn is next. Okay, so if it's a winner, then the status shows the winner. If there is no winner, the status is the next player. Okay, we could do that. And then how are we displaying the status? The status is just some text. Oh, it's just some text. Okay. All right, let's try that. Where is board? Board is right over here. So let's get rid of this winner stuff. Okay, so right after we handle the click, outside of handle click, we're gonna do, let's see, we're gonna create status. Okay, so we're gonna figure out who the winner is. So we need to define a winner, right? We're gonna store a variable we're gonna have a variable to figure out, to store who the winner is after we call calculate winner, right? After we do that, we're gonna check. So if there is a winner, we're gonna check if there's a winner. If there's a winner, okay, so we'll let status, so constant status, so what did it do? Okay, so we predefine status. So why do we use const here and status and let over here? Let's ask ChatGPT. So in the tutorial, we are almost done. Quick question, why do we use const sometimes and let sometimes? Okay, so const lets us declare a variable. So when we declare a variable with const, it creates a constant variable, meaning the variable's reference cannot be changed after initial assignment. Okay, so the reference can't be changed. This ensures the value remains the same throughout the scope. Let is used to declare a variable with block scope. Okay, I see. So let lets us reassign the variable with a new value. Interesting. Okay, 1 second. I'll grab a tissue. Okay, so winner returns a consistent value that represents the winner of the game. I see. So winner never changes after we declare it once, but the other variable changes. Okay, that's fair. Okay, so next square never changes. That's correct. How about in this case? Let changes. What else doesn't change? Winning combos don't change. All right, so we're using these properly. The only thing we're not using properly is this one. So status will change, right? The status. And then winner, we're gonna make status is gonna be equal to the winner. Okay. And then if there is no winner, the status is gonna be the next player. And that is going to be, how do we get the next player? So we define this one, right? X is next. So if X is next, we're gonna try to use the fancy question mark syntax. If X is next, then the answer is X. If not, then the answer is y. Cool. All right, so does this work? Refresh this x. Okay, first of all, we forgot to add the status there, but that's okay. Let's use our React Dev Tools and see if we can see. Okay, so we cannot see the variable. That's fine. Let's make a component. So right above here, we're gonna make a div, and the class name, I think it's already predefined in our CSS. It's gonna be called status. And then we're gonna put inject the text status. Cool. Okay, let's try it one more time. So there's a weird X over there right now for some reason. Status is X. Oh, I see. So the next player is X. I don't know why it didn't add the next player. Convert to template string. Okay, so JavaScript apparently has template strings. That's cool. So is X is next right now? No. Okay, so X. Oh, all right. This is not being updated. Okay, so it is being updated if winner, if else it's not being updated. Why is that? Why is status not being updated if it's a winner? Interesting. We just have X there. So status is, let's see what we're doing wrong. Oh, I see. So maybe it's an order of operations issue. Oh, okay. Do you guys see the problem? This is the problem. The main problem is that this is a ternary, this question mark is a ternary operator. So basically it means it takes everything in front of it. If it's true, it's X. If it's false, it's Y, right? What is everything in front of this question mark? Everything in front of this question mark is this stuff. So this is saying the string next player plus X is next, which is gonna be equal to a string, right? So let's do a console.log. Console.log. Next player plus false. That is, let's look at the console. Next player false. Next player true. Is next player true? Do these evaluate to true or false? Let's see. How do we evaluate? If, let's just do true, false. True. This always evaluates to true, even if I have false here. So the problem is that we should have put this in parentheses. That way the scope of it is correct. And now it's complaining that we did not expect a comma. And why is that? Where did we put a comma? Is that a... Okay, that was a mistake. Okay, cool. So this is pretty cool. It says next player is X. All right, so I want to be the middle. Next player is Y, and the next player is not Y, it's O. Let's try that one more time. X, O, X, O, X. And the winner is X. Woo! This is pretty cool. This is super fun. So we've gotten to a really good state, guys. We're basically at the point where we can track the winner of this game. Like, this game is basically done. The only problem is we can't replay the game. You can only play it once before you have to refresh it. But this is actually really cool. We've gotten really far. We've made a live tic-tac-toe game with React. And okay, so it cannot detect ties apparently, but that's okay. Can it detect winners? It can detect winners though. So maybe in the tutorial they're gonna teach us how to detect ties. I feel like we already know how to detect ties. Let's try that. So let's look at where we are and let's talk about what we're gonna do. It's already been an hour of streaming and I wanted to finish the tutorial, but because I talk a lot, we are not able to finish the tutorial. But we're almost there. The last part is doing time travel, which allows us to go to backtrack in steps, right? I think that's gonna take a little longer than like a few minutes, so let's put a pause on that. Instead, what we're gonna do is we're just gonna try to add detecting a tie ourselves, and then in the next stream, which I'll do tomorrow, hopefully on YouTube Live, because YouTube should have approved it by then, we'll finish up this tutorial and then we'll be done with the first React tutorial. And that's a huge milestone into making this application. And I'm so sorry about my nose. I think I'm allergic to something today. Yeah, I think it's going to be a huge step towards us making our application, because this lets us make interactive JavaScript applications. This is super powerful, right? So how are we going to make a tie? To detect ties, it's pretty simple. Let's go back to desktop. To detect ties, we need to check if all the arrays are filled, then we will declare it's a tie. And there's no winner, it's a tie, right? So let's just call this. And this is probably not the best way to do it, but it's one way. Detect tie. We're gonna do squares, right? So we'll take in all the squares. And how do we detect a tie? We're gonna do for every element in squares, if there is no null, okay, let's check empty, is full. So we're gonna keep track of, is the board full yet, right? So the board is not full right now. Okay, so the board is, the default state is the board is not full. Or let's say the board is full. That'll be the default state. And then we're gonna check and then make that false if we see some null value, right? So if squares, if one of the squares, I'm so sorry, I'm coding in Python even though this is JavaScript. So if squares I is not null, is equal to null, if it has nothing, then, and what's the problem here? Okay. Oh, I'm so sorry. I don't know what I'm doing. Squares I is equal to null. I don't know why my JavaScript is not coming out today. There we go. So if a square is empty, then is full is false, right? Because that means that there was an empty square somewhere. Okay. And the return is full. Cool. And you can probably simplify this, but let's just keep it like that for now. And how are we going to use this? Well, to use this in the tie situation, okay, so nobody can mess with the game anyway because the board's full already. We're just going to skip that part. But in this status part, if winner, so if there is no winner, else, If there is no winner, then if is full squares, else this, right? And what is this? Is full is not defined. Did we not define it? Oh, tic-tac-toe. Let's call it is full. Okay, so if it's full, then we're gonna return status is tie. Else we'll show the next player. It's a tie. Okay, let's see if this is working. Okay, so let's try to make a tie game. Harder than I expected. It's a tie! Cool! This is pretty cool, right? You guys think it's pretty cool? So we're able to make a tie. Like this is awesome, right? This is the fun part of coding. Like I love coding because you can basically make something on your own without anything. Like you just write some lines and the computer does it for you. It's awesome. It's the most satisfying part of coding when you work on something and it just does what you want it to do, right? So let's try it. The condition, let's do a win. If I can make a win. There, winner is O. And yeah, so I think we're basically done with this section of the tutorial, and I can't seem to make a tie. I just want to play with the tie part. Okay, I need to concentrate on not winning against myself. Just kidding. Oh. Okay. Keep winning against myself. No, I'm forcing myself to win. Okay, let's try to not let myself win. Okay, finally. So it's a tie. You can see it's a tie. This is cool. This is fun, you know? This is what I live for. All right, so next time we see each other, we're gonna continue on to the next part of the game, which is adding time travel. This is exciting. We're gonna have to, looking at the outline on the bottom, we're gonna have to lift the state up once again. But that's for tomorrow. Let me know what you guys think in the comments. Let me know if you guys want more of this content. I'm thinking of starting a second series where we learn some machine learning. I really want to get into machine learning as well, and maybe machine learning can be a great tool for our application that we're working towards. Just a reminder, we're trying to build an application to help students discover what kind of careers they want to have, right? This application, let me see if I can pull up my iPad real quick. Show you guys what we discussed a while back. Stream to you guys. Okay. So just a little bit of a reminder. We're doing all of this because we want to build a web application to help some students figure out what their career path is. And in order to do that, we want to make a kind of like a mind map application of sorts. Let me draw it one more time. So the application will be like a little cloud with little items on the edge, and this is like careers. Cannot write in midair. Careers, and then these would be like bio, like science, language, math, all different types of interests, right? It doesn't have to be scientific. It can be like fun interests, maybe sports. And then when the user clicks into one of these, it zooms in to sports. And it can tell you what type of careers are in that area. And then eventually, when you get down to it, it'll find you the career, and then you can see a sample schedule that somebody in that industry does on a day-to-day basis. I wish I had this tool when I was a kid, because I knew that I wanted to do electrical engineering, but I didn't actually know what electrical engineering did every single day. If I knew what the electrical engineers did every single day, I would have been much more prepared, and I would have studied more software, because I didn't realize software is so fun. Yeah, so this tool would be pretty cool if we can make a web application where everybody submits something like Rate My Professor, except it'd be like, rate my job, or not rate my job, but describe my job and then give a little bit of a summary. I think this will be a great tool for students to use and discover what they want to do in the future. It's been the 6th stream, and we haven't asked ChatGPT about our progress. Let's update ChatGPT about our web app progress. So, hi ChatGPT. We are like 4/5 done with the React app tutorial you mentioned. You told us to go through. We still would like to make excuse me, guys. Yeah, it's really dusty. I don't know why I'm sneezing so much today. Make our web application. We will continue our progress, but just want to keep you updated. I realize you guys can't see what I'm typing. Just want to keep you updated. Please let us know if you have modifications to our daily schedule. We have been following what you suggested since. I'm glad. So ChatGPT says, I'm glad you're making good progress. As long as you're finding the current daily schedule resource helpful, I recommend continuing the same approach. Keep following the tutorial and learning at a pace that feels comfortable for you. If you have specific questions, I'm here. Take breaks, blah, blah, blah. So ChatGPT is giving a very robotic answer. But yeah, that is it for today. I really appreciate you guys tuning in. Like I said before, we have a Discord channel. Please feel free to join us on the Discord. I would love to have some live interactions with our viewers. I hope transitioning to YouTube Live tomorrow will get more live users. And if we have some live input on Discord, it'll definitely make the recording more colorful, and it'll be more useful for whoever's watching this, because I can get like actual feedback. And if you get stuck somewhere, I can help you out. I just want to build a community where everybody can learn together. I really want to learn this myself, and I really want to make this application to help people. And if we can do it together, all the better, right? It's always lonely learning by yourself, but if you have a group that learns together, you can make a lot more progress than you would have had by yourself, right? So please join our Discord. I'll show the Discord link. Let me pull it up. Give me a moment. Discord is starting, but please join the Discord and we can talk over there. Let me find the link again. All right, this is the link. All right, so I'm gonna submit the link on Twitch chat. Okay, there you go. So it's on Twitch chat. If you're watching this on YouTube, it's a recording. So I'll put it in the comments for you to join. Don't be shy. We're all very friendly. There's a couple of us in there right now, but if you join, you'll definitely not regret it, and you'll love the process. I'll guarantee you that we're gonna learn so much together. We're gonna use ChatGPT more, and yeah, I really thank you for your time, and I'll see you tomorrow. Good luck.